Okay, everybody, we're going to continue on with the Pythagorean theorem today, and we just have we've got a diagram here that looks a little bit different than maybe what we've seen in the past. So what this is just another way of looking into Pythagorean theorem. Now, we have some squares attached, and you can see that there's a right triangle on the inside there. So maybe what I'll do is I'll just get that, yep, there with the right angle, pardon me, and then we'll maybe color that in any color other than black, just so that we can see that triangle so it's not too much of an illusion there. Perfect. And then maybe the entire triangle. Perfect. And then that way you guys can just kind of see which triangle we're talking about. So while this is being done here, perfect. We're going to look and see what we know about this triangle. Now, we know that the Pythagorean theorem is a squared plus b squared equals c squared. Now, let me just get that finished. Perfect. So in this case, a squared we know will end up being an area. So we know already that a squared is 36. So in a question like this, you get to skip that math. So a we'll call 36 just because it's there on our left-hand side. And then you can see at the bottom, it's a little bit longer. It has an area of 64. So that square is 64. And we can do that math, but before we do that, I just want to label what A is. So A would actually be that line segment that's connected to the triangle. And that would be A. So just so you guys know exactly what we're talking about. B would be the other leg because it's connected to the right angle of our triangle right there, and that would be B. And then C is the hypotenuse. So Pythagoras, he was a really smart guy like we've talked about, and his whole idea is that the two squares, so our one square that has an area of 36 and our second square that has an area of 64, those added together will give us the exact area of the square of the hypotenuse, or that big one that we don't know yet. So, we're just going to quickly go 36 plus 64. And if my math is helping me out here, that should equal 100. So 100 equals c squared. So maybe what we'll do is we'll just put 100 in that big square so we know what the area of that is. Now, if I wanted to know what A was, or what B was, or what C was, and because of where C is, we'll just deal with C. Now, we want to solve for that variable of c squared. So the best way to get rid of a c squared is, again, to take the square root of c squared. So we'll do that. And we know that because it's an equation, what we do to one side, we have to do to the other. And what it works out to is the square root of 100 is, in fact, a perfect square of 10. So 10 equals c. Now, we're not quite done there. I want to figure out what a is. We know that a squared is 36. So if I wanted to do that, I would have to take the square root of 36. Now, we won't have to write all that on the board because it'll be too confusing, but I do know that a is going to be 6 because 36 is also a perfect square, and 6 multiplied by 6 is 36. Therefore, a will be 6. Now, b has an area of 64 for b squared, so if we were to take the square root of 64, we know that b is equal to 8. So we now know that this is a Pythagorean triangle, or a right triangle, that has two legs, a leg of 6 and a leg of 8, and a hypotenuse of 10. Now, one thing to keep in mind, this is called a Pythagorean triple, which is when you have three squares that are all perfect squares connected in a right triangle. So you have 3, 4, 5. This one is 6, 8, 10. And if you guys want, I want you to think about 2 or 3 other right triangles that would be considered Pythagorean triples. So if you see a question like this, I don't want you to be afraid. It's just giving you more information, stuff that you would try to solve first. This time they've done a little bit of the groundwork for you. So do your best on these, and I hope that this Flip It lesson has helped you guys.